Hi, I'm Aditi Pathardikar, and today I'll be discussing about complex systems named op-amp or operational amplifier. Op-amps are complex systems made of resistors and transistors majorly that are used in various devices and analog circuits. In the next few slides, I'll be explaining the use of op-amps using some examples, and also before that, I'll be explaining a bit about op-amps, what they actually are. Op-amps. The operational amplifier or an op-amp is an integrated circuit that can amplify weak electric signals. An operational amplifier has two input pins and one output pin. The basic role is to amplify the out and the output voltage difference between the two input pins. So as you can see in the figure, this is an op-amp and this is a non-inverting pin and this is the inverting pin and this is the output. So according to the relation, the V output will be equal to some constant times V non-inverting minus V inverting. So if the voltage inverting increases, the voltage output will decrease. But if the voltage inverting is increasing, non-inverting is increasing, then the voltage output will also increase. Here the A is approximately of order of 10 to the power 6 or something. So the first example that I take up is voltage follower. The voltage follower is an op-amp circuit whose output voltage is equal to the input voltage. This circuit allows for the creation of a very high impedance input and low impedance output. Hence, a voltage follower op-amp does not amplify the input signal and has a voltage gain of 1. Here, this line, the circuit allows for the creation of a high impedance input and low impedance output. This is because the current that's drawn by the op-amp is approximately equal to 0 and hence leading the impedance to be very high. So here as we can see in the diagram, the Vs and the VE terminals are connected together and that's why they both are equal, and hence the V output and the V input ratio is just 1 because the V V non-inverting is grounded. Now to explain the use of the V of the voltage follower, I'll be using a problem in a circuit. The figure is based on a voltage divider and the circuit cannot function. Indeed, the load impedance can have large variation, so V output voltage can change dramatically, mainly if the load impedance has value of the same magnitude as R2. Here, it means that if the resistance of the load is comparable with the R2, then for every time the load resistance changes, the V output will change and hence will vary all the time. This is something we need to contain from happening. So the use of voltage follower in this circuit. To solve this issue, an amplifier between the load and the voltage divider is inserted. Thus, the V out depends on R1 and R2 and not on the load value. So here as we can see, the V out will just depend on the V input that has been provided by R1 and R2 and the voltage across it. So it will be independent of the voltage of the load resistance. Next, I'll introduce the inverting op-amp. In this configuration, the output is fed back to the negative or inverting input through a resistor R2. The input signal is applied to this inverting pin through a resistor R1. The positive pin is connected to the ground. All this explanation we can see in the diagram happening. Here it is to be noted that the V output and the V input are in opposite phase because of this negative sign. Some special case which is commonly used of inverting amplifier is this is evident in the special case where R1 and R2 are equal. This configuration allows for the production of a signal that is complementary to the input as the output is exactly the opposite of the input signal. Due to the negative sign, the output and input signals are out of phase. If both the signals must be in phase, a non-inverting amplifier will be used. This is the use of the and the application of the inverting amplifier is in the trans resistance amplifier which is also called a transimpedance amplifier. This amplifier works as a current to voltage converter used in less power-based applications because of its high input impedance and low output impedance. Inverting amplifier is used at the output stage when a system is designed with different sensors. And these are the two examples I used. And thank you.